I'm going to be solving question 59 for the night textbook. This question says, you come into a lab one day and you find a well-insulated 2,000 milliliter thermos bottle containing 500 milliliters of boiling liquid nitrogen. The remainder of the thermos has nitrogen gas at a pressure of 1 atmosphere. The gas and liquid are in thermal equilibrium. While waiting for the lab to start, you notice a piece of iron on the table with 197 grams written on it. Just for fun, you drop the iron into the thermos and seal the cap tightly so that no gas can escape. After a few seconds have passed, what is the pressure inside the thermos? The density of liquid nitrogen is 810 kilograms per meter cubed. So first we're going to want to find the heat that it takes. So that's just going to be our equation. Q equals mass, specific heat capacity, delta T. So the mass of the iron given in the equation is 197 times, and then we're going to convert that, so it's going to be times 10 to the negative 3 kilograms. Specific heat capacity we look up is 449. The temperature is room temperature minus the boiling point of nitrogen. So room temperature is 300 Kelvin and the boiling point is 77. This gives us 1.97 times 10 to the 4th joules. Next, we're going to find the extra mass of nitrogen given the equation when it is vaporized. So in order to calculate that, we use Q over LV. LV is the vaporization of liquid nitrogen, which we can look up. It's a value that we look up. So Q, 197, 10 to the negative positive 4. And then the value of LV is 1.99 times 10 to the 5th, which gives us 0.099 kilograms. We're also going to find the extra moles, so we'll use the mass, and we divide that by the molar mass in kilograms, which is 0.028 kilograms per mole, and this gives us 3.54 mole. And finally, we were going to want to find the volume extra, so again using the mass, but this time we're going to divide it by the density, which was given to us in the original equation. And we get 1.22 times 10 to the negative 4th meters cubed. Okay, now that we have the extra values, so these are all extra, we want to find the moles original, which we're going to use our ideal gas law equation. So PV equals nRT. So in this case, we were going to have moles times pressure, or moles equals pressure times volume on the top. So pressure, since it's a insulated thermos, we're going to assume that it's at perfect pressure, which is 101 times 10 to the 3rd pascals. The volume we are going to use is 1,500 times 10 to the negative 6 meters cubed. And this is the volume of the gas nitrogen before the heat transfer. And now on the bottom we have R, the gas constant. And T, we're going to use the boiling point, so 77 Kelvin. This gives us 0.237 mole. And then we're going to want to find the total moles, which is this value plus this value. And that gives us 3.78. And then the volume total, this value times, or plus this value, which is 1.62 times 10 to the negative third meters cubed. Now finally, to find the pressure inside of the thermos, we're going to use the ideal gas law equation. So we want to find pressure 2. And in order to do so, we're going to use the total moles times RT over the volume, the total volume. So as you saw in the previous paper, total moles is 3.78. R is 8.31. And T is the boiling point of nitrogen again, so 77 Kelvin. All over volume, total volume, which was 1.62 times 10 to the negative 3 meters cubed. After doing some calculations, we get 15 atmospheres. So this is the pressure inside of the thermos after a few seconds have passed.